Hello students, welcome to Rao's IAS Focus Weekly. Today on the date of 5th of March 2025, I am discussing the current affairs in the subject of science and technology of the past 1 week. I am covering the current affairs from 27th of February 2025 till 4th of March 2025. Although in this past 1 week there have been discussions, there were news related to science, somewhat more news was there, but I found that most of the topics we have already covered in the past, either DNS or in the Focus Weekly. Now I have shortlisted these 3 topics that I'm going to take up today. The first topic is NASA SPHEREx telescope. It is a new observatory that NASA is planning to launch to do an all-sky survey of the universe. Then we'll talk about the SIDE report. It is basically State of India's Digital Economy Report 2025. It's a very special report dedicatedly made as per the standards of the developing countries. And then we'll talk about an interesting new material called the Bose metal, inspired by the Bose-Einstein condensate, the Bose-Einstein statistics. We'll talk about these 3 things. Let's start with the first topic. The first topic is NASA SPHEREx mission. Now the NASA SPHEREx mission is going to be the latest observatory that NASA is planning to launch. It is almost built. It is just that any day we may hear this particular observatory to be launched. Although as per the official website of NASA, it says that the observatory is not going to be launched anytime before 6th of March 2025. So today is 5th, so we can expect any time in the next week, in the next 1 week. Now what is this SPHEREx? So SPHEREx stands for spectrophotometer for the history of the universe. So you can easily guess that this particular observatory is trying to study the origin or the history of the universe primarily. Then it will also study the epoch of reionization. Reionization epoch basically talks about the origin of the universe, origin of matter and all these stars, stellar origin and such. And then it will also be studying the origin of IAS, basically the creation of water molecules, which can be essential for growth of life. So this is what the SPHEREx mission will be looking for. It will also perform an all-sky spectral observation in optical as well as near-infrared light. Optical and near-infrared light means it will take images. It will take images in the optical spectrum, that means visible light, just like what humans do. And also it will take images in the near infrared light. Near infrared light is that light which actually is not, our eyes are not sensitive to the near infrared light, but this light carries a lot of information, because if an object which may not be visible to us, but it has a certain heat, it has a certain energy, the near infrared light would be able to capture those images. And this will give us a much broader understanding of the universe beyond what a human eye can observe. So optical and near infrared. Remember, whenever the word optical comes, it is mostly related to visible light only. Then next is this mission will work for 2 years in total. Within these 2 years, SPHEREx observatory will collect data of more than 450 million galaxies of the universe. It will gather the data of nearly 100 million stars of our Milky Way only. And that's how it will try to create or understand the overall origin of the universe. It will try to study the origin of the universe as well. Now, within the Milky Way, SPHEREx will try to study the presence of water and organic molecules, which are essential for life. It will also try to study interstellar nurseries. Interstellar nurseries are those regions where stars are created, where gases and dust particles accumulate, which essentially create new stars, and around the stars, new planets also. So interstellar means within the star. Interstellar means between 2 different stars. So interstellar within the star nurseries, which are supposed to create new planets, right? So they are the places where new planets are formed. We call them interstellar nurseries. Now, when you talk about this SPHEREx further, the SPHEREx will also create an all-sky map. It will create a map of the entire universe with 102 different color bands, which is going to exceed all the previous maps that have been made so far on the entire universe. So this becomes an even more visionary initiative, where we'll see the most detailed map of the entire universe with the help of the SPHEREx mission, right? And then guys, this would enable studying the universe right after the Big Bang. Yes, guys. So what has happened after the Big Bang and how the universe have progressed since then, it will help us to study that. And as per the NASA website, the launch will take place only after 6th of March 2025. So this is what we have under the NASA SPHEREx mission. Guys, UPSC have shown a lot of affinity towards asking questions from various international initiatives. So European Space Agency, NASA, these two are good agencies from where a lot of missions have been asked previously, right? There was another probe. It was Proba 3. Proba 3 was a probe that was launched by the European Space Agency for studying the sun. So it was a solar observatory of European Space Agency, right? Even that was also news, and that was also in news. I'm planning to take up Proba 3 and the stellar and the solar observatories of India as well as USA Punch mission most likely next week. I think this was in today's news, right? On 5th. So most likely next week I'm going to discuss these, right? I hope all of you guys have been able to understand. The next report is the State of India's Digital Economy Report. It is called the SIDE Report of 2025. Now, why this report is very important, guys? There is a special reason why this report has been given some weightage. The reason is, guys, there are already so many reports on AI, so many reports on digital economy. When I talk about digital economy, it talks about the penetration of internet among the people, accessibility of internet, infrastructure of internet dispersal. Then it also talks about the issues or preparedness against cybercrime, hacking. It also talks about sustainability, that how far internet is sustainably used in a country, how inclusive it is, and what has been the penetration of the services that internet normally provide. Are people only watching videos, or are they using other services as well of the internet? Now, there have already been a lot of reports on the similar issue. Like we have reports from International Monetary Fund, IMF. We have reports from United Nations also. So there are a lot of prestigious organizations who have come up reports previously. But what have been observed, that all these reports have shown a certain biasness, towards developed countries. They have often tried to gather the data of the developed countries much more elaboratively, much more extensively compared to the data of developing country. So there has always been some lack of clarity in terms of sharing the real image, the real picture of the growth of digital economy in developing countries. So guys, here there is a Dutch investment firm called Proces and an Indian think tank called Indian Council for Research on International Economic Relations. It is a Delhi-based think tank, guys. They both have together introduced the State of Indian Digital Economy. I hope you understand why this particular report is fundamentally important. Now, this report has used a framework called CHIPS. This was also there in the 2023 report. In 2023 as well, the side or this report was introduced, and this report uses the CHIPS framework. CHIPS means they have parameters based on connectivity. They have parameters based on how much of internet is being harnessed by people, how many services are being offered on the internet, how many businesses are using internet and its potential. Then it talks about innovation in internet, how much fintech companies is one innovation in the internet, how much internet based businesses are being set up, right? Quick delivery apps and such. Protect stands for safety regarding internet, right? The protection against cybercrime, the preparedness of the government against cybercrime, the awareness of the people against cybercrime, all these things, right? You guys must have heard of digital arrest. It has been one of the major issues in the year 2024. And then it also has sustain. Sustain basically covers the area of sustainability, right? That how much sustainable is internet of the country, how far it has been it is being helping in promoting sustainable development or reduction of damage to the ecosystem, right? How much is the use of renewable energy in providing internet and such. So these are the 5 areas which are considered under the SIDE report. And guys, they measure the scale and depth of all these 5 areas, and that's how they have compared India with other countries. So the parameters mostly involves technological infrastructure available, the societal use of internet, the economic impact of internet, and policy driven aspect of digital transformation, right? Aadhaar, you guys know, it is the world's largest ever citizens inventory. You guys know about various other initiatives like Arogya Setu, Cowin platform. There have been so many platforms where Government of India has directly used Aadhaar based data for providing services, for providing better services and governance. So this basically shows, or these are the parameters that shows that in India there is a wide scale use of internet and digital economy, but this is where we wanted our own platform, our own report to highlight these things. So guys, there were 32 countries that were part of this report, and these 32 countries comprising of 17 developed countries and 15 developing nations, where India's score was 11th position in terms of AI based research, 16th in terms of AI based infrastructure. So this is India's position. And when it comes to the total digitization, India stands third in the world, only after China and USA. Only after China and USA, India stands third in the world in terms of digitization, right? And then lastly, we have, when we combine both country level and user level digitization score, India's ranks drops to 8th. So when you talk about country level, and user level, that means how much people. So in terms of country, we are having a much better stats in terms of research, infrastructure and digitization. But in terms of individual, in terms of user level database, user level digitization, our rank drops. So it clearly shows that we are doing far better in terms of infrastructure. We are doing far better in terms of the country level use of internet. But when you talk about the penetration of internet and the penetration of digital economy for users, for people using these services, that is still little less. So you can understand that most people are simply using internet for social media, videos and such. They are not becoming a part of digital economy as such, right? So that is where India ranks 8th in the world. Then guys, the last topic of today's discussion, it is related to Bose metal. Now this report has come recently in the Hindu newspaper. It was a research team which has done something significant in understanding or in realizing the Bose metal. Now what exactly is Bose metal and why it is called Bose metal? First of all, guys, it is called Bose metal because it is somewhat related to the work of Albert Einstein and Satyendra Nath Bose. I hope you guys know Satyendra Nath Bose happens to be probably one of the first quantum physicists born in India or produced from India, and he has worked with Albert Einstein, and they both have together come up with properties of matter. They both have come up with properties of matter, studying the properties of matter at extremely low temperature. And while studying these properties, they both even discovered the fifth state of matter. We guys normally consider solid, liquid, gas as the 3 stages. The 4th stage is plasma. Bose-Einstein condensate is considered as the 5th state of matter. So when Einstein and Bose together studied matter at very low temperature, they created a lot of properties. They created a lot of statistics which are supposed to be the properties of matter exhibited at extremely low temperature. Guys, when I talk about extremely low temperature, it means temperature tending to 0 Kelvin, guys. What is 0 Kelvin? It is equal to minus 273 degrees Celsius. So when you try to reach to a temperature closer to minus 273, not exactly minus 273. So when you try to reach that minus 272, you will notice that matter happens to behave in a slightly different way, right? And it tends to behave more or less related to, or more or less similar to, what Bose and Einstein together figured out as Bose-Einstein statistics or Bose-Einstein condensate. So what is Bose metal? Bose metal is basically not an actual metal, but it is considered to be a metal that is anomalous in nature. Now what do you understand by anomalous metallic state? Anomalous means, let me just take one property, and that property is one way how these students have been able to discover. So guys, when you talk about metals, we all know that metals are very good conductors of heat and electricity. They are good conductors of heat and electricity. And we know that metals, they conduct electricity even at room temperature. But you know what? When you start decreasing their temperature, when you start lowering down their temperature, please mind my words, right? Listen to this very carefully. So when you decrease the temperature of metals, we discover that metals tends to improve in terms of their conductivity. So their electrical conductivity improves as you decrease their temperature. So ideally, if the temperature keeps on decreasing and decreasing, the conductivity of the metals should keep on increasing. right? And there is a time when it is called critical temperature. Critical temperature is that temperature when a metal attains a state of superconductivity. Superconductivity is that state where the metal has zero resistance. That means you send some current from this end to the other end receives the same current without any loss in between. Without any loss in between, we call this temperature as we call this temperature as critical temperature, and this conductivity is called superconductivity. So technically, every metal, when you start decreasing their temperature, has got a critical temperature where they start reflecting or they start behaving as a superconductor. Superconductor means zero resistance, maximum possible conductivity of heat and electricity. So every metal has got a certain critical temperature. Now what these scientists have found, that when we start cooling down the metals to a extremely low temperature, when we start cooling down metals to an extremely low temperature, that means a temperature closer to absolute zero, they tend to see that metals happens to behave in a slightly deviant manner, in a slightly anomalous manner. Anomaly means error, in an erroneous manner. So normally the metal's conductivity should keep increasing and it should behave like a superconductor. But in the case of Bose metal, at an extremely low temperature, minus 272, 272.5, metals happens to behave like Bose metal. That means it behaves like metal, but also shows some properties which are different than an actual metal. That's why it's called the anomalous metal, right? It's called the anomalous metallic state. That means it shows some properties similar to a metal, but some properties not similar. And that's why it is called the anomalous metallic state. Now guys, to be honest, for UPSC, this much is enough. For UPSC, this much is enough. That what is Bose metal? It is a metal that works on the idea of Bose-Einstein condensate, and it is supposed to be created at a very low temperature. But guys, this is just the theory. It is just the theory. An actual practical Bose metal is yet to be created. But yes, scientists in Japan and China has performed some research where they have found that yes, they have found elements behaving, atoms behaving slightly similar to what Bose-Einstein condensate talks about, Bose-Einstein statistics talks about, and this is the reason why it was in news. So I don't think there is a need to dive anywhere deep, but I'll just give you a simple idea that as a metal turns into a superconductor, electrons are able to take current very fast. Electrons tends to move extremely fast, right? But in the case of Bose-Einstein condensate, the electrons are still able to move, but it does not show superconductivity. It shows better conductivity than metal at room temperature, but does not show superconductivity. So that's basically the idea of anomalous nature. That is what basically the Bose metal is. And this is the simple reason why it was in news, because it is still considered as mostly theoretical, but we expect that as some research is happening at absolute zero temperature or nearing absolute zero temperature, we are learning more and more about Bose metal. Guys, knowing Bose metal happens to help us a lot in knowing how conductivity, superconductivity works. It also helps us to learn how exactly different types of matter can behave at an extremely low temperature, how different matter may behave at an extremely low temperature. So this is what we have under the study of the Bose metal, right? I am already sharing this entire PPT with you, so you guys can read and understand what the Bose metal is, and you can also write to us right on the comment section, and if you have any questions regarding Bose metal, anything, I think you may have questions on Bose metal, I'll be happy to address them in the next Focus Weekly. So guys, this is everything for today. We'll be meeting next week. All the best.